Everybody, I'm Rashid. So I'll continue this talk here, and we got to 7.4, which is the mean. All right, and this definition, the simple mean or average of the simple of n numbers is, as you know, you add and you divide by n, right? For this example, uh, I didn't put table one, so let me give you table one. So the weekly sales at a dealership A are five, let's say six, four cars, 8, 9, 10, 11, and the number of occurrences which is the frequency. All right. So compute the sample mean for the weekly sales of dealership A that we also saw in section 7.1, 7.2. And this table has these numbers. So we can form the mean the way we did it before. And all right, so let's do it here. So we can do the mean to be we have 5 times 2. We have 6 times 2. We have 7 times 13. And we have 8 times 20. We have 9 times 10. We have 10 times 4. We have 11 times 1. And if we add these, let's double check. I know from previous example it's 52, but let's just double check. So you know what's happening. All right, yeah, so that's correct. So here we're dividing this by, so this is the top here, this top, just to continue, and the bottom is going to be 52, right? Okay, and we get 7.96. Of course, you'll ask, why did you multiply these this way, right? And so let me just give you the formula directly, because I didn't try to use, you know, the probability and stuff. So let's just give you the formula directly. And now you can see that, oh, this is what happened in this example, because we're talking about the sample mean, right? And that's in this example here, it's asking the sample mean. So if you suppose you have an experiment that has outcomes of the numbers x1, x2 to xr, suppose that the frequency is x1, of x1 is f1, the frequency of x2 is f2, and so forth, which we'll have in that example, right? When it says here number of occurrences, that means the frequency. So if you add up the frequencies, which I did, I got 52, then the mean can be calculated by x1, f1, x added to x2, f2, and so forth. So the sum in math, we can also do something like this: xi fi over n, right? Or you can do 1 over n xi fi, where I is going to go from 1 to n, or let's say r, right? If you see this symbol somewhere, that's what it means. We're going to say x1 f1 plus x2 f2 and so forth. So another way to do it is this way, but I don't usually use it that way. I would use the sum formula. So let's now, you know, as you understand statistics and you understand the difference between a sample and a population, then the formula, if you have n, which is a capital N for the population, and the population mean is denoted here by this mu, it's given by x1, x2, and so forth, which is the sum of xi over n, where I is going to go from 1 to n. Okay, so let's do an example here. Life expectancy of a deer. And of course, we want to see what we're dealing with. So an ecologist observes the life expectancy of a certain species of a deer held in captivity on the basis of a population of 1,000 deer. All right, a population of 1,000 deer. They observe the data shown in table 2. What is the mean life expectancy of this population here? So age at death is 1 until 9 years. Number of observance, which is the frequency, is 0. 2 years, 60 times, and so forth. So if we want to change this to relative frequency, then we're going to add, of course, the number of deers. Which we have already 1,000 right here. So we're going to do the observed. So relative frequency is going to be the observed over the 1,000, which is there. So the mean here is one times this one is just 0. So for 2, if we do this, so let's do these calculations. If you do 0 by 1,000, you get 0, and the other one 60, you get 0.06, you get 0.18, 0.25, 0.20, 0.12, 0.05, 0.12, 0.02. All right, so you divide using this formula the observed by 1,000, right? So here we complete this 0.06 times 0.18, 0.25. So this one, this one, this one, this one. Next one is this, which is a 5. a 6, a 7, an 8, and a 9, and that's done. And you try these, you get 4.87. So the mean life expectancy of the population of a deer, the mean of this deer is 4.87 years. Okay, so in summary, we have, you know, to figure out the mean, if you have the frequency, all right, then you will use the formula, all right, divided by n. And so here, so here we have few ways to use it, right? We can use add and multiply all these, or we can based on this way. As I mentioned, I don't much use this one, but I used it for this example to show as well that if you follow the relative frequency, then you want to check. Here it's kind of easy because it's 1,000, so you're getting this kind of fixed numbers. Then in that case, you're using the relative frequency times the whatever outcome you're measuring. And you know, and at the end it gives you the idea, which is good. So the takeaway here is we did an experiment observing for 1 year, for 2 years, and this, and how many observance here. Then when we put this data together, we were able to find the mean life expectancy for this deer population.